Hey everyone, and welcome. Today, we're going to get right into the heart of your computer, the one single component that really dictates how much power you have. We are, of course, talking about the processor. Look, whether you're a gamer, a creative pro, or you just want your computer to run a bit smoother, understanding this little piece of hardware is absolutely the key.
So, have you ever stopped to think about that? You click an icon, and you wait. Or maybe your machine is just lightning fast. What's the secret ingredient? Is it the memory? The hard drive? Yeah, those things are super important. But the real engine, the part that does the actual thinking, well, that's something else entirely.
And there it is. The processor, or the CPU, is literally the brain of the whole operation. It's the small chip that sits on your motherboard, but it's responsible for executing every single command and running every program you use. It's simple, really. The more powerful the brain, the faster your computer can think and act.
Okay, so let's get into it. Here's the game plan for this explainer. We're going to start by decoding all those confusing specs. Then we'll take a tour of the marketplace to see who the big players are. After that, and this is critical, we'll cover how to make sure your new processor is actually compatible with your system. And to finish it all off, we'll do a quick and easy guide to installation.
All right, first things first. Let's take all that technical jargon you see on a product page and turn it into knowledge you can actually use. Seriously, understanding these terms is your first step to making a smart decision, so you know exactly what you're getting for your money.
So when you look at a processor spec sheet, these are the heavy hitters. These are the things that really determine its performance. We're talking about everything from its raw speed to how it juggles multiple tasks and even its own little high-speed memory bank. We're going to break down a couple of the most important ones right now.
Okay, multiprocessing might sound super complex, but the idea is actually pretty simple. Think of it like this. Having multiple cores is like having a team of workers on a project. Each one can tackle a big task. Now, multi-threading, that's like giving each of those workers the ability to juggle two smaller tasks at the same time. So, more cores and more threads just means your computer can handle way more at once without breaking a sweat.
Here's another game changer, the memory cache. So imagine the processor's main job is grabbing data from your computer's big memory banks, the RAM. Well, the cache is like a tiny, super fast tool belt it wears. The processor keeps its most used tools and data right there on the belt, so it doesn't have to walk back to the main toolbox every single time. A bigger cache means faster access and a system that just feels way snappier.
All right, so now that we kind of know what we're looking for, let's meet the main contenders in the ring. When you go shopping for a processor, you are going to see two names pop up again and again and again.
And yup, those two names are Intel and AMD. For decades, these two giants have been in a constant battle to build the fastest, most efficient processors for everything, from your basic laptop to the most insane gaming rigs and massive data centers.
Generally speaking, Intel has a massive range of products. They power a huge number of the desktops and laptops you see on store shelves. AMD, on the other hand, has become incredibly popular, especially with PC builders, gamers, and enthusiasts, because they offer really powerful performance, often with more cores, at super competitive prices. So yeah, if you're buying a pre-built computer, odds are you'll see Intel inside. But if you're building your own rig, especially for gaming, you are going to find a ton of amazing options from AMD.
To make sense of Intel's lineup, all you really have to do is look at the numbers. The Core i3, that's your starting point for everyday stuff. The Core i5 is that mainstream sweet spot for most people, great balance of price and performance. Then you've got the i7 and i9 for high-end users who need some serious horsepower for gaming or creating content. And at the very, very top, the X series is for absolute extreme performance.
Now, let's flip over to AMD. Their Ryzen family follows a really similar pattern. Ryzen 3, 5, 7, and 9. The higher the number, the better the performance. But then they have the beastly Threadripper for desktops, which is aimed at professionals who need a frankly ridiculous number of cores. And for the server world, get this, their EPYC processors can pack a staggering 64 cores onto one single chip.
And you know what? It's not just an Intel versus AMD world out there. There's another major player, especially in the devices you carry in your pocket every single day. ARM processors are designed completely differently, with a laser focus on efficiency. Their low power and low heat design is exactly why they absolutely dominate the world of smartphones and tablets.
And now we've arrived at what might be the single most critical part of this whole thing. You could have the best, fastest processor in the world, but if it doesn't work with your motherboard, it is just a very, very expensive paperweight.
So let me be super clear about this. Compatibility is everything. It doesn't matter if you're building a brand new PC from scratch, giving an old machine a new lease on life,
or just replacing a broken part. You have to get this step right. There are no do-overs.
And compatibility really just boils down to two things, the socket and the chipset. The socket is the physical shape of the connector. An AMD processor just won't fit in an Intel socket. And sometimes even different generations from the same company use different sockets. The chipset, think of it like the motherboard's translator. It has to know how to speak to the specific processor you're installing. So before you buy anything, you always have to check your motherboard maker's website for their list of supported CPUs.
Okay, you've done your research, you have double-checked compatibility, and your shiny new processor has arrived. Now for the fun part, putting it in the machine. I know it might sound intimidating, but it is actually one of the most straightforward parts of building or upgrading a PC.
So here's the whole process in a nutshell. You're going to open a small retaining lever on the motherboard socket. You'll carefully take out the new processor, holding it by its edges. Do not touch the pins underneath. You'll align it, drop it gently into place, and I mean gently, no force needed, and then you just close the lever to lock it all in.
But how do you align it? This is the most important part, so listen up. Processors and sockets have little markings on them, usually a tiny gold triangle in one corner. All you have to do is line up the triangle on the chip with the triangle on the socket. That one tiny detail makes sure it's oriented perfectly and prevents you from accidentally bending and destroying hundreds of delicate little pins.
And that's pretty much it. From understanding the jargon to actually installing the hardware, you are now equipped with the core knowledge you need about your computer's brain. So it leaves us with one last thought. We've seen processors go from a single core to dozens of them, from sluggish to unbelievably fast. As this tech keeps getting smaller and smarter, what do you think the next big leap will be? What's the next revolutionary change that will completely transform how we use our devices every day?